So I made this recording so that you could watch, I guess, a general overview of the course on your own time, and hopefully give you a chance to maybe think about things before we actually had our meeting. So I'll start off at Blackboard. I've been teaching this course for about 6 years, so it's pretty well established, and that's why I'm kind of excited about getting some commentary on it and some fresh perspective. So the course is based on a modular concept. I have right now 13 actually developed pieces of programming and then a final project. And every course or every module contains both objectives, the lecture in video format, and a link to slides of that lecture, because a lot of times the slides are hyperlinked. And these are playlists, so the lectures can be divided off into components. And then I have some additional resources. Some of these things I cover, sometimes I don't, depending on where I think the class is at. This is where they submit their projects when they complete it. And then after the lecture component, they have a lab component, and it's all driven by videos. And once again, this is segmented off into a playlist with a bunch of segments, and they typically have a running time to them. And I try to indicate this over, like that's 66 minutes of project video. We have a really long period project that might be almost 2 hours. And that is intended for a student to be able to hopefully complete the actual work on their project within the 3-hour lab. And typically when we get into something that's maybe 120 minutes, that's 2 hours. At the worst, a student might spend as much as 6 hours, and some students will only spend maybe 2 hours on the project. So that's the setup with Blackboard mostly. I have some additional resources on here that I've developed over the years to, I guess, help deal with some situations. The other thing I wanted to maybe mention is also during lecture, the lectures are usually 50 minutes long, and I add a in-class project for the remainder. I find that they really only have, I guess, just any of us have the attention span of a good 50 minutes. And so we do an in-class active learning project, which is kind of a mini lab project, and they do that on their own. And I'll outline what those are when I go to the specific slides. So I've moved over to the slides now, and this is, well, we've already covered, this is the schedule, layout of lectures and labs and active learning. I'll leave this on the screen. You can read it for yourself for a second if you want. This is the kind of basic course description. And then I wanted to step through each one of the projects, I think, which is the meat of what's really going on with the course. So this is the first project they start off with. It really helps me to assess if I have any troubled students, if they're late getting to set up with Revit or use the lab facilities. And it's basically the idea they start off with a building and they copy and duplicate and modify components. So that's modifying and placing windows, organizing them, getting them to space equally, changing doors, roof systems, and eventually kind of an evolution of an architectural type, starting out with a hip roof and going all the way to kind of a commercial storefront flat roof building. And that's a pretty good assessment of where students are when I get started with the course. Then we move through a series where we're going to make a small commercial building. Once again, I always have a focus on this idea that in architectural practice, the bread and butter of the practice is in commercial work. And so I kind of make a focus on that. We start out with a grid system. We actually do design work, backwards from what architects might do as far as programming, developing form and shape, and building from there through schematic design. We actually start as if we're contractors building a building. We start out with laying out a grid, 20-foot spacing. That helps to give students the idea of scale, and a bit of an introduction to parametric design. We then go ahead and place walls, foundation walls, and then a footer underneath. We add the steel components in order to support the floor systems, and we start to build the brick facade. And that's the first part of that series. And the next one, we pick up on that building and we start to add a facade, storefront glazing system. We add floor systems. We learn the terms of parapet and spandrel. And we continue to look at ways and modes of presenting our information in our presentation sheets. Once we've gotten our building pretty far along, I take a little bit of more examination on this idea of creating presentation sheets and technical sheets. So in this project, we take the same building and we render it in two different styles. This gives the student the idea that even though the BIM modeler makes things look very complete, we have ways of presenting it to our client and through process that make things look much more flexible or in process. So we go through the sketch mode, we remove materiality and learn how to render it that way. At the same time, we look at the technical drawings that are produced with the same BIM model. We develop our floor plans and our foundation plans. We develop some elevations. We learn out how to lay them out on a sheet. We then cut some section cuts through the building and learn how to detail specific components in that section cut. We go back now to the outside and we start to, in this next series of experiments or experiences, we create a bespoke or a custom awning. I try to introduce students to the idea that that they're not just finding things on the internet, they're creating them themselves and even these little specific components like this awning system. So they learn how to model glass and aluminum kind of structural system in order to create this bespoke component. We work with the site development. We learn how to create the pavers around the building, curb work in order to locate the building. We start to insert doors, start to look at applying railing systems and an internal stairway. And at the same time, we then go back and we see basically how that has updated our technical sheet. I take a break from that building because the next thing we're going to do, we spent a lot of time in that building and I thought it might be just time for them to see some other kind of an experience. So we look at the idea of space frames. They learn how to create an adaptive component and then spread it out over a curvilinear surface and then apply structural supports of adaptive columns. So they develop two kinds of adaptive componentry and then learn how to apply those. And then they finish it off by building a little bit of site context around that. We then go back into the building that we've been working on, that commercial building, and start looking at creating interior detailing. We spend a lot of time creating bespoke components. The countertop here is completely fabricated. The desktops are Revit family models that we create. The actual monitors that sit on the table are custom created. We look at the idea of ceiling clouds and creating different kinds of shapes and lighting systems to be placed in them. And we get an introduction to ray traced rendering inside the Revit environment. And once again, we look at always the idea of the presentation sheet. Everything is always being submitted on one single sheet. And we discuss the ideas of layouts and ways to modify the ways our drawing and our model is presented. So we pretty well completed that project. And I now work to the idea of sweeps and some other kinds of traditional details on buildings. And this is a project that HHL has just started in the city of Buffalo that's been around for 3 years. I thought the building was really attractive and had a lot of nice features in it that we could use as a learning tool. So students learn how to create a facade, the bump out to add sweeps and trims and embellishments, learn how to customize their windows a bit. Learn how to make exterior wall type components with sweeps of caps on them, exterior stairway systems. They get a big kick out of being able to have flexibility in doing planting, their own planting layouts. Show them how to introduce grass systems, tree beds or breakouts in the sidewalk here. And once again, we experiment with rendering and different types of lighting techniques. In kind of a preparation now for construction tech, this has been in the last few years, we've started to look at helping to prepare students to make the kind of technical drawings that they need to for, well, construction tech and some of the comprehensive studio work. So here we make we have a really long discussion about what BIM can do and what it can't do. We look at making a 3D model, we place windows in it, and we then see that a lot of components are missing: the headers, the sills and top plates and things like that, the insulation. So I show them, though, that if they really take a bit of preparatory time and create a really well-detailed wall with drywall on it, and sheathing and finish systems, that once they cut that section, they can extract a lot of rich detail from it. So we look at what detail the BIM provides, and then how to amend it in order to create an elegant, or I guess not, maybe elegant's an overstretch, but an accurate portrayal of a construction detail of a wall section. Once again, I have a real heavy focus on this idea that architects do commercial work as the bread and butter, as I've said, and I look at introducing them to more complex curtain wall ideas. So we work on making an adaptive component, which is a curtain wall module. We look at making baguettes. We add multiple features to that component. So at some points we can express it as being a clear piece of glass, and other times by clicking a button we can express it as being a piece of solid mass, as these kind of columns are. So they walk through this. I don't think they get we don't really develop this enough for them to completely congeal the idea of what's going on here. But I think it needs work, or it needs a little bit of expansion, and that I haven't really attacked yet. In a way I have, though. I guess this next slide might show it. We take that module, and you can see it here, this white module I'm rolling over here on the right. That's the same module from our project. And I give them a Revit file that has both this tiled, I believe it has this tiled finish and an aluminum finish, and no drawing. And I have them lay out a grid system, and then I have them work back and forth modulating the facade in order to create this kind of, I guess, just more complex or visually interesting facade system. This is just to break them from the molds of using one single wall tool. They look at how to open up a window system or a wall to make a larger window system. They learn how to use a canned component that they've already created. Once again, I really love some feedback on this. The week after that, we do a check drawing. This is actually I guess the base level check that students have accomplished some of the goals within computer viz. I think it's a relatively low bar, but the concept here is the check drawing is provided on the left, and the drawing or the details for it. I try to create a complete narrative about the layout. I talk to them about creating a grid and then developing, and I show them this silhouette or this schematic of what the floor plan would be. And then I ask them to put all different kinds of materials, roofs, and window systems in, and then to report them on a drawing sheet, an E1 30 by 42, and that's on the right here. And this would be a typical output from that narrative. And like I say, it's a low bar. I don't put a lot of pressure on them. Most students are rewarded that it's kind of a feedback that they've learned all the necessary skills within the software in order to do these kind of basic CAD drafting functions. We pick back up then in that week on a project. So we take that module of that articulated facade, and we use it in a site. We put it into a site near the campus that's kind of a rolling, topographically complex footprint. I doubled the building up in order to make it look a little more expansive. They learn how to create these kind of outdoor, I think they're not subregions. I forget what they are right now. They learn how to build retaining walls and just deal with the exterior nature of it. They learn how to take an actual aerial view of a satellite image and then translate the information of roads onto the topographical model. They import the topographical model from one that I provide for them. And we do a little more with topography, and I'll explain that in a minute. We finish this course off by introducing them to Dynamo, parametric node-based programming. The idea is, I guess the strong underlying thing is here is design without actually drawing anything or drawing very little. It's really just coding. This started out as a wall facade, but I found over the years I hit on the idea that the dynamics of it really work more effectively if I use it as a ceiling system. And the idea here is they learn how to code to create these boxes, and then they learn how to influence the length of those boxes by relating it to a curve. So on the right here, I'm rolling my arrow over a curve that is on the floor, an imaginary thing that shapes the geometry above. And the calculations in the node-based programming say, as things get further away from the curve line, they get longer. As they get closer, they get shorter, basically. And so in order to manipulate the shape of the ceiling system, you actually manipulate the shape of this curve. And so you can imagine that the curve could be actually a walking path through this, and it could be reflected in the shape of the ceiling system. We have a final project, and I think that's going to shift from year to year. I'd love some input on that. It really, I really try to make it this idea of all the skills you've learned in the course, putting them together. Many times students are already working on in-class or studio work, and so it might just be an expansion of that. I could just drop the whole idea of a final project, or I guess make it more technical. Would love some input on that. And along with all the things that are happening with the projects and the lectures, there's that in-between space where I call it the in-class active learning. And we do a lot of little mini experiments. So, and I say mini, it takes them probably 30 minutes to an hour. Some take longer. We look at form studies, light studies, facade development, some modifications of a shipping container. I'll just show you these images as we go through them. So first thing is, just don't put a window in a wall. You can do all kinds of things to modify that kind of opening. We look at form studies. We create conceptual masses, and then using a Revit tool, we can apply walls and curtain wall glazing systems to that. And so we do just two different styles of freeform massing. We look at light studies. We do two different light studies. We do one where we just make a building and or a box, I guess, but probably a better term than a building. And we cut some openings in it, and then we examine it at different times of day with the actual play of light on the floor. And that just introduces them to that tool, so that in the next in-class module, we actually create, we do ray traced renderings to look at real illumination levels, and we create a window system that is actually parametric. So we can change the size of the opening of the window by changing a number to it, and then re-render it to see the effects on natural lighting in that environment. We spend some time looking at brick. We do two different experiments. I make a big point out of students with thin brick today. People are placing windows with trim over the face of the brick, but it's really not the way historically accurate to the way brick systems are constructed. So I show them how they can take that same window and recess it, and then build sills and lintels. So they just do a quick study on that. And that gets them set up for a little more elaborate facade development. We look at creating column systems, hierarchy of column systems, a major column, a minor column. We do some sweeps. We look at just the idea of the play of light and shadow when we create this depth. So it gets them started, I guess, with some ideas of what's happening in our historic facades. They get a chance to manipulate a shipping container. That's always a classic project or thing that people think is cool, to modify a shipping container. And it's really problematic in our BIM modeler because Revit doesn't understand the shipping container as having walls or floors, so you can't place components in it. So this is a real jump start to help students understand how to use some of the modeling tools in order to make it do the things they want to do. And once again, for prep for construction tech, we look at just an initial idea of window and door schedules. I provide them with a floor plan. They go ahead then and create a layout, this sheet layout, where they create legends and door and window schedules for that layout. So that hopefully gets them started for what happens in construction tech. They get a chance to, once again, I was talking about in topography, we actually create a freeform topography, so we invent a surface instead of importing one, and I show them how to do that, how to create the idea of a flat surface and water, and then we just put a building on top of that in order to create some kind of a setting. And I think the last thing we do in these in-class exercises, at least currently, is we look at Pbr textures. They're physics-based rendering textures. The idea is they have a three-dimensionality to them and some alternate states to create these really highly realistic and very simple to create kind of textural systems that could be used to create really detailed brick systems or other types of deeply textured materials like pavers, but also create accessories facades like to do urban infill. You might create some generic types of buildings to go along with the building that you have in the site. So it introduces the student to these enhanced textures, and they're available in Revit, and Revit doesn't make that very clear that tool is available. So I think that really concludes that kind of introduction. It looks like it's taken me almost 20 minutes, which is a little terrifying to go over that. So you could probably watch it at twice the speed. This is my field notes for things I need to fix. So thanks if you took the time to listen to that. Appreciate it.